Okay, I'm going to do question 6 from exercise 11D. That's demonstrating how to find an area under a curve using integration. And we're going to be using definite integration here, so integration between two values for x. Okay, we're asked to find the area of both R1 and R2. Now to start with, I'm going to do R1. And before we go about doing anything else, I'm just going to tidy up this diagram a bit so we've got the important bits for this part of the question. Okay, there we go. Then I've just removed R2 for now, so we can just concentrate on the yellow area of R1. Now, if we're integrating, obviously we're going to be doing definite integration. We're going to be looking at the integral between this point here and this point here. Now, the first problem is we don't know what these points are, so we've got to find those to start with. Now these points are where the curve y equals x squared plus 1 and the line y equals x minus 7 intersect. So to find those points, I need to set those lines equal. So x squared plus 1 equals 7 minus x, because we're trying to find the values where, okay, we're looking along that curve and also along that line. So that's when those two are equal. So to sort this out then, first of all, turn it into a quadratic of the form ax squared plus bx plus c equals 0. So the x squared can stay there. This minus x needs to come over to the other side, so it's plus x. This 7 needs to come over to the other side, so we get 1 take away 7, which is minus 6, and that equals 0. Now you should see that this is going to factorise to give us x like that. Now we want two numbers that have got a difference of 1 but that multiply to give us 6. That's 2 and 3. The fact that we've got a negative sign here means that one of these must be negative. We've got a positive 1x, so it must be this way round. That gives us the solutions x equals 2, because 2 minus 2 is 0, and x equals minus 3, because minus 3 plus 3 is 0. So that means that this point here has got an x value of 2, and this point here has got an x value of minus 3. So we've got the limits of our integration here. We've got the two values that we need to integrate between. Now to find R1, it's not a simple case of just integrating one of these two. We've got to have a look at how it's been made up. So if we have a look, first of all, at what happens when you integrate y equals 7 minus x between those two limits. Oops. So it's going to be 7 minus x with respect to x between 2 and minus 3. Now when we do that and work that out, that's going to give us the area that looks like this. So if we carry out this integration, it's going to give us this orange area here. It's going to give us the area under the line y equals 7 minus x between minus 3 and 2. Now if we have a look at what happens when we integrate under this curve here, so if we do the integral of x squared plus 1 with respect to x between 2 and minus 3, that's going to give us the integral between here and here under that curve. So that looks like this. So that will give us the red area here. So if we have a look at what we've got now, it becomes clear that if we want to find this yellow area, that's this orange area, take away that chunk of the red area. So to complete the integration, what we need to do is work out the integral of this take away this. So we're going to be doing the integral between 2 and minus 3 of the first one, which is 7 minus x, take away the integral under x squared plus 1 with respect to x. Now if I tidy that up, I'm doing the integral between 2 and minus 3 of, well, I'm going to be left with 7 minus 1, so it's going to be 6, minus x squared with respect to x. Now when I integrate that between 2 and minus 3, so 6 is going to become 6x to the 1 divided by 1. That's going to become x squared over 2. And this is going to become x to the power of 3 over 3. And we want to evaluate that now between 2 and minus 3. Now, when I substitute these values in, so I'm going to do, first of all, what happens when I substitute 2 in? Now, that becomes 22 over 3, and you can check that using your calculator. And then I'm going to be subtracting negative 27 over 2. So this then becomes obviously 22 over 3 plus 27 over 2, and that gives me the answer 20 and 5/6. So the area of R1 is 20 and 5/6. That's the question done.